Imagine a world where your software doesn't just run, it evolves. Like a living organism, adapting to its environment. That's the revolutionary vision behind EvoGraph, a framework that's redefining software development by turning legacy systems into self-improving ecosystems. Let's dive into how it works, why it matters, and how it's rewriting the rules of code modernization. Here's the problem. Enterprises are drowning in legacy code, massive, outdated systems that struggle to meet modern demands. Fixing them is like rebuilding a house while living in it. Traditional tools. They can generate code, but they can't handle the mess of build files, fragmented documentation, or hidden business logic. And when automation fails, it breaks performance, breaks integrations, or worse, introduces security vulnerabilities. But what if software could learn to fix itself? That's where EvoGraph steps in. Think of it as a self-driving car for code. It doesn't just write new code. It evolves existing systems by testing changes, learning from mistakes, and selecting the best improvements. At its core, EvoGraph uses a directed graph, a map of every component in a software system. Code, documentation, build files, even tickets and logs are all connected here. Each node is like a puzzle piece, and the edges show how they interact. This structure lets EvoGraph see the big picture, not just isolated lines of code. Now, how does it evolve? EvoGraph leverages small language models, SLM, specialized AI tools that are faster and cheaper than large models like GPT. These SLMs act as expert editors, making precise changes. Code patches that fix bugs without breaking other parts. Doc sync that keeps manuals up to date in real time. Build weaving that updates dependencies or compiler settings. Cross-language translation, like turning COBOL into Java with 93% accuracy. But here's the magic. EvoGraph doesn't just make changes. It tests them. Every mutation is evaluated against strict criteria: security, performance, functionality. It's like having a team of 24/7 quality inspectors. And when something goes wrong, safety gates stop unsafe changes before they cause chaos. The results? Let's talk numbers. In real-world tests, EvoGraph fixed 83% of security vulnerabilities. Translated COBOL to Java with 93% functional equivalence. Kept documentation fresh within 2 minutes. Cut development latency by 40% and sped up feature delivery 7-fold. And it's not just about speed. EvoGraph's approach tackles deep-rooted issues in legacy modernization, like hidden, implicit contracts between systems or the risk of breaking performance when updating code. By focusing on the entire system, it avoids the pitfalls of piecemeal fixes. Let's get technical. EvoGraph uses quality diversity search, a method that balances innovation with reliability. Imagine solving a puzzle not just by finding the best solution, but by exploring many approaches while tracking their quality. This ensures changes are both novel and high quality. The system uses a formula to prioritize code updates, favoring ones that are safe, efficient, and aligned with business goals. But how does it stay safe? Enter the safety gate. Before any change is deployed, it must pass rigorous checks. Does it pass all tests? Does it follow interface rules? Is it not too different from the original? This prevents crashes or security issues, which is critical for mission-critical systems. Now, let's talk about the algorithm. EvoGraph starts with a copy of the existing codebase and generates thousands of variations. Each version is tested, and the best ones are selected to create the next generation. It's like natural selection for code, only the fittest survive. What makes this system unique is its use of small language models, SLMs, like Phi-2 or Nemotron-H. These models are smaller and faster than GPT-4, but still powerful enough to understand and rewrite code. Plus, they're way more cost-effective. Why does this matter? Let's look at the numbers. In tests, EvoGraph fixed more security vulnerabilities than human experts using AI tools, reduced system latency by 40%, and cut documentation lag from hours to minutes. For example, translating 12,000 lines of COBOL to Java required 58% fewer manual edits compared to raw AI translation. And the cost? EvoGraph used 90% fewer GPU hours than larger models, making large-scale modernization feasible for budget-conscious teams. What's really exciting is the multi-language capability. EvoGraph isn't just for one type of code. It handles COBOL, C, Python, Lisp, and more, each with specialized models trained on their unique patterns. This means companies can modernize entire systems without rebuilding them from scratch. But here's the kicker. EvoGraph isn't just about speed or cost. It's about safety and precision. By combining AI with rigorous checks, it reduces the risk of errors that could cripple systems. And the future? We're talking sharded graph encoders for massive codebases, AI that learns from runtime behavior, and even federated evolution across private systems. The goal? To create software that's not just functional but adaptive. EvoGraph isn't just a tool, it's a paradigm shift. It's proof that AI can go beyond generating text and start re-engineering the very systems that power our world. Whether you're a developer, a CTO, or just a tech enthusiast, this is a glimpse into the future of software. Stay curious, keep learning, and let's build better systems together.